Same quadratic, same maths, still wrong. Let me show you one of the easiest ways to lose marks in exams. In this video, we look at a quadratic optimization answer that is mathematically correct, and still wrong. The turning point lies outside the allowed domain, and that single oversight costs multiple marks. In this exam question, this is where good students lose marks. Because the turning point is outside the allowed interval, the maximum height must come from the endpoints. We're given the height of a ball, h of t equals minus t squared plus 6t plus 5. Where t is time in seconds, and the model is only valid for t is greater than and equal to 0 and less than and equal to 2. Most students immediately find the turning point. Using t equals minus b over 2a gives t equals 3. And they stop there. But here's the problem. T equals 3 is not in the domain. The exam trap. Finding the turning point, t equals 3, and using h, 3, as the maximum height, even though t equals 3 is outside the stated domain. Common loss of marks. Students correctly identify the turning point but fail to check whether it lies in the given domain. This leads to an impossible global maximum for the context. What examiners reward? An explicit domain check followed by selecting the maximum from the allowed interval, often at an endpoint. Using h, 3, is a context error. Examiners don't care if your maths is right if your answer isn't allowed by the question. Here's the exam rule. After computing the turning point value, immediately ask, is it between the given endpoints? If not, evaluate the endpoints. Suggested VCAA style mark allocation, 6 marks, finds the turning point using t equals minus b over 2a, checks the domain and recognizes the turning point is not allowed. Uses endpoint reasoning for a closed interval. Correctly evaluates h, 0, correctly evaluates h, 2, and selects the maximum. Identifies the exam trap, using the turning point outside the domain. Common loss of marks. Although the turning point is correctly identified, many students do not verify that it lies within the specified domain and consequently state a maximum value that is not attainable in the context of the question. Because the turning point is outside the allowed interval, the maximum height must come from the endpoints. We check, h, 0, equals 5h, 2, equals 13 so the maximum height is 13 meters, and it occurs at t equals 2 seconds. Before you move on, here's a final exam trap checklist. These are the mistakes that cost the most marks. Before giving a final answer, pause and check 3 things. First, what is the question actually asking for? A value of the function, or an x value? Second, have you found the turning point correctly? Third, and most importantly, does the turning point lie inside the given domain? If the turning point is inside the domain, then it gives the maximum or minimum. If it is outside the domain, do not use it. Instead, check only the allowed values, endpoints for a continuous domain, or nearest permitted values for a discrete domain. Choose the maximum or minimum from allowed values only, and make sure your answer makes sense in context, time, units, and realism. Exam rule to remember, the turning point is not the answer unless the domain allows it. After you find the turning point, don't stop there. Always ask, is it actually in the domain? If it's not allowed, it can't be the answer, no matter how good your maths is. Subscribe for more VCE exam traps you need to avoid.